In Unit 1, Homework 7, we're looking at graphing quadratics. Now we've looked at solving quadratic equations before, which will help me find my roots or my intercepts, but there's also quite a bit more to graphing quadratics. So first of all, I want to give you a rundown of some different types of quadratics that we're going to be running into. Now it's really important that we look at some MyMathLab problems in this section as well, because in MyMathLab they're going to be asking you to use the graphing tool to graph, and I want to make sure you're familiar with that as well. So before we get started, when we're graphing quadratics, we could be graphing things, let's say like y equal, let's do x squared plus 2x minus 8. Well, if we looked at y equal x squared plus 2x minus 8, the first thing I would notice is that this is positive. It's an implied positive. And because it's an implied positive in front of the squared, this means this is a parabola opening up. I could also look at another equation, let's say like y equal negative x squared minus 2x plus 15, and here I notice that my value is negative, and so because it's a negative, this is a parabola that opens down. A parabola is this U shape. This is probably not the best example of one, but it's this U shape. Now it's not parallel, it's not U like this where both the sides end up being parallel. It keeps extending out indefinitely in either direction, getting a little wider on either side. So that's our basic shape of a parabola. We won't be looking at parabolas that open on their sides, which would be a y squared instead of an x squared. We're just going to be focusing on the x squared type of parabola. So to get started, when we're looking at a parabola, the first thing we want to note is whether it opens up or down. It opens up if the leading coefficient, which means the coefficient in front of the squared term, is positive, it opens up. And it opens down if the leading coefficient is negative. So those are two important things to keep in mind. Now also when we're talking about graphing a parabola, we like to be able to talk about things like domain and range and vertex. So let's go ahead and start defining some of those things. This is a vertex. It's either the highest or the lowest point on a parabola. So we can see here that the vertex on the right is a maximum, because it's the highest point. Now over here on the left, the vertex is the lowest point, so it's called a minimum. So when we're starting to graph, those are some of the things that we want to keep in mind are things like vertex. Is it a maximum or a minimum? Well, if it opens up, if the leading coefficient is positive, I have a minimum. And if the leading coefficient is negative, it opens down, I have a maximum. So those are some of the things that we can keep in mind. Now, and a couple other things that we like to talk about are domain and range. So the domain for any parabola opening up or down is all real numbers. Okay, so domain, we'll use D for domain. All real numbers mean negative to positive infinity. And that's usually how we'll represent that when you're working on any of these types of homework problems. Now the reason it's any real number is there's no restriction. I can plug anything I want to in here. There's no square root, there's no fraction, there's nothing that restricts my values. So that's the domain. However, the range is different. The range will change depending on whether it opens up or down. And whether it opens up or down means whether we have a minimum or a maximum point. Okay, so from here, let's look at two examples. Let's say we have this minimum point, and let's say the vertex at this minimum point is 1, negative 4. Okay, so remember, range means our vertical values. Okay, so range means our up and down values. Well, the minimum point here on my y-axis then would be negative 4. So the range here would go from negative 4 to positive infinity, because vertically it's going to start here down at negative 4 and move up toward positive infinity. Now I'll bracket the negative 4 because I actually reached that value. I'll have a parenthesis on infinity because I never actually quite reach infinity. Now if I have a parabola opening down, And let's say this is the ordered pair. I'm just making up values here. Let's say this is 1, 6. So my y value is 6. So again, I'm looking at this and I'm thinking, okay, my vertical values, I have vertical values. So vertically, it looks like to me that all my y values start toward negative infinity. And of course, I never reach negative infinity, so I have a parenthesis. And then we'll go all the way up, and then we'll touch this value right here, which is 6 on my y-axis. And it's a bracket because I actually touched that value. So the range will change depending on whether it's opening up or down, so that's something that we always need to keep in mind. Now another thing that we can talk about is axis of symmetry. Axis of symmetry means what cuts this in half. So here, the axis of symmetry, I can see, is this x equal. So here my axis of symmetry is x equal my x value, which is 1. This is my axis of symmetry. Now in my other graph, the axis of symmetry is x equal 1 as well. Because again, it's the x value that splits my graph in half. The axis of symmetry has to do with the x value. The range has to do with the y value, and of course the domain is x value as well, which corresponds to all real numbers. So again, axis of symmetry will always be for a parabola that opens up or down, x equal, and then of course we fill in whatever the x value of the vertex. Vertex is either the highest or lowest point. So that's what we fill in here. It's the equation x equal. Now we can also talk about intercepts. When we talk about intercepts, we have two types. We have an X-intercept, and for our X-intercept, this is where it crosses the x-axis. This is where y equals 0. So that's the X-intercept. We also have the Y-intercept. This is where it crosses the y-axis. And this is where x equals 0. So if we were to draw a picture talking about intercepts, you might have a case where you have a y-intercept. So whatever this y value is, this is a y-intercept, and no x-intercepts. So this would also be the case where we'd have no solutions if we were to try and solve this because it never crosses the x-axis. We could also have a case where we have, let's open down this time. So we have one x-intercept, and we have one y-intercept. Now if you notice with the y-intercepts, that's the most you're ever going to have is one y-intercept. With the x-intercept, you could have 0, you could have 1 as we do in this case. Okay, and then we could also have something like, let's say we're a parabola opening down. Here we have a y-intercept, so we have 2 x-intercepts. So these 2 x-intercepts are here and here. So for x-intercepts, we could have 0, 1, or 2. The y-intercepts are usually pretty easy to find because we just plug in x equals 0. The x-intercepts are sometimes harder. So what we're going to do is we're going to take all of this information and we're going to go through and we're going to start graphing quadratic functions. Now there's going to be a lot of different ways we do this, and one of the ways that we're going to do this is by using a couple of formulas. So these are helpful formulas. So when we talk about these helpful formulas, the first one is the vertex of a parabola. And I'm going to show you how to do these on your calculator as well. The x value for the vertex of a parabola is equal to minus b over 2a. And then the y value, I would just plug in the x value to find that. Now where does the minus b and the 2a come from? Remember, the standard form of the equation of a quadratic is ax squared plus bx plus c equals 0. So the a and the b, that's where they come from. Now another nice formula to know is the standard form of a parabola. Now we can graph many parabolas in non-standard form. Sometimes though, if they're given to us in standard form, it's easier to work with. Now basically, to get this in standard form, we do some completing the square, and it's not necessarily that we'd be able to put things in standard form, but if they already are in standard form, they're kind of nice to be able to work with. So this would be kind of what a standard form would look like. A x minus h quantity squared plus k. Okay, well, what are all the a's and h's and k's mean? Well, if it's in this form, I know my vertex instantly. My vertex is the opposite of the h. So in this case, the h is negative, so we'd say h, and it's whatever the k value is on the outside. So opposite h and the value of k. And then whether it opens up or down would be the value of a. So if a is greater than 0, it opens up, and it opens down if that coefficient out front is less than 0. So those are some things that we can look at while we're graphing. So I think to get started, I just want to go ahead and jump right in and pull out some MyMathLab questions so the wording is familiar and so are the types of solutions you can look at. So let's go ahead and look at one of the first problems that you'll have in MyMathLab. Now for this particular problem, they give you a graph and they ask you to identify the equivalent equation. Now if you wanted to, you could go into your calculator and graph each one of these. That would be an option. But I think the other option I want to go with is I want to start with that idea of our standard equation, our standard formula for a parabola. That's a y equal a x minus h quantity squared plus k. Now remember, our vertex is at hk. Now first of all, this is a parabola that opens up, so each of these values in front should be positive, and they are, so I can't get rid of them from there. And then I can look at this point right here, this vertex. So if we look at this vertex, my x value is -1, -2, -3, and my y value is 1, 2. So my vertex is -3, 2. So if I wanted to figure out which one of these went with a -3, 2, what I need to remember is, in here I need the opposite, and out here I need the actual value. So a general form for this parabola, and I don't know what the value of a, that doesn't end up mattering here, x minus my x value of my vertex plus the y value of my vertex. And again, I'm not going to be able to figure out what the a is just from the vertex. But this should be what the general form looks like. So where do I have a +3 and a +2? Looks like letter C. So that's going to be the fit here because I have the +3 and the +2. So remember, the x value is opposite and the y value is the actual value. So these are kind of some of the problems that you'll be running into again in MyMathLab. Let's go ahead and pull open a few more. Now, when we're looking at these problems, again, if you can, graph them. But having said that, I really don't want to graph 4 problems for the last example that we looked at to find the one that matches, but you could if you wanted to. So if you get in a pickle and you don't know what else to do, you can graph each one of the 4 options and then work from there. Okay, now here it says choose the correct equation below. But if you notice, what's happening here is I know my vertex, and the vertex is the point -2, 0. But these aren't in standard form, so that's not very helpful to me. So I might want to think about the vertex as also being, in this particular case, the X-Intercept. And then I also see up here, I have a Y-Intercept. And this Y-Intercept is at 0, 4. So for these types of problems, there's more than one way to work them, of course, but one thing that I might suggest is trying to figure out from the intercepts which is the correct function. And again, you could graph each one of these as well. So using the Y-intercept, if I let x equal 0, if x is 0, y is -2 here, and that has to be 4, so I know it can't be this one. If I let x equal 0 here, I get y equal 4, so that has potential. And if I let x equal 0, I get y equal 2 here, which means that can't be the right answer. And for this one, if I let x equal 0, I get y equal 4. So it looks like to me right now it's a contest between B and D. Okay, and so for letter B, I have x squared, I've better write them out again since I kind of crossed them out. I have x squared minus 4x plus 4, and D, I have x squared plus 4x plus 4. So now let's go ahead and go after the x-intercept. Now the x-intercept means if I set y equal to 0. Well, that's not going to be, I'd have to do that with two of these. I think what I'd like to do is to use that x equal minus b over 2a here. So minus b would be minus a negative 4 all over 2 times 1 would be 4 over 2, which is 2. So this one has an x-intercept of a positive 2. That doesn't work, so cross that one out. Now over here, let's go after that minus b over 2a as well. And I have a negative 4 over 2 times 1. Here I get negative 4 over 2, negative 2. That matches. So the correct answer here would be letter D. And again, you could graph each one of these on your calculator as well to see which one lined up. But there's several different ways to figure out which one is the correct equation. And again, graphing always works too. So kind of working through these, now we're going to talk about the idea of maximums and minimums, and so we have to think about what a vertex is. And remember, a parabola that's opening up has a minimum, and a parabola opening down yields a maximum. And it just has to do with the opening up or down part with that vertex. Oops, we have to recapture that one because we don't want to have that blocking out part of the problem. Okay, so it says write an equation in standard form of the parabola that has the same shape as the graph of 7x squared or negative 7x squared, but with the given maximum or minimum. Okay, so we're looking at standard form here. We have a couple things to look at. Standard form. Okay, standard form. So that would be the a x minus h quantity squared plus k. So I need to know a vertex here. I'm guessing this a is going to be 7 or negative 7. But look at, they tell you the maximum. So if I know I have a maximum, that must be a parabola that's opening down. So that tells me I'll use the negative 7. Now this maximum point will be right here. Now if we want to try and figure out what the x and y values are for this maximum point, you need to remember the y value will be the maximum, and it already tells us the x value is negative 8 here. So this is the ordered pair negative 8 for my x value and 7 for my y value. So this is the vertex. Now we can use this value of the vertex to put this in standard form. Remember, we said we're going to use negative 7x squared because it's a parabola opening down. So my a value is going to be negative 7. Okay, and then I have my x minus h. Now h is going to be, so here with my value for h is negative 8, I'll have x minus a negative 8 quantity squared, and then plus my k value. Now k is my y value, so plus 7. Now rewriting, I have negative 7 minus a negative is the same as a positive, so this is x plus 8 quantity squared plus 7. So this is going to be what we use in my math lab. Now they already give us this h of x, which is synonymous with the y. So the only thing that we need to put in is the negative 7 portion over here. So that's the portion that would go into my answer blank right here. Now if we were to plot this on a Cartesian coordinate system, my vertex would be at negative 8 and up 7. So it would be right here, and it's opening down. Now we don't really know how wide it is just from these two pieces of information, but we could figure out how wide it is doing a little bit more curve sketching over here. Another thing that we could do is to plot this on your calculator, plug in this equation and see what it looks like when we graph it to see if we do indeed get this vertex of negative 8, 7 with a maximum of 7 when our y value is, or sorry, when our x value is negative 8. So we can see here when we graph that, I kind of jumped ahead. We went into y equal, graph the equation that we came up with, and then of course we can go to second calc, and we know we're looking for a maximum, so that's option 4, and it says to choose a point to the left of the maximum, and a point to the right of the maximum, and then our maximum value turns out to be -8.7, just like we expected it should be. Let's go ahead and take a quick screenshot and plop this into our lecture so we can kind of compare it with what we have for our quick little curve sketch. Okay, so if we plop this in here, we can see that the maximum value is definitely in the second coordinate like it is over here. And my maximum is at x equal -8, which this says it should be. And my maximum value is at 7. So this worked out perfect. So it's always a good idea to go through and double check your answers with your graphing calculator as well. I want to graph this first. So this is already ready to graph, 2x squared minus 8x plus 10. So let's go ahead and pop our calculator in here. So y equal, so we have our 2x squared, so 2, here's our variable, 2x squared, okay, minus 8x plus 10. Now sometimes we'll have to change our scale, see what's happening here. I think I do want to change my scale here. I can see that it's not crossing the x-axis, but I kind of want to get more of an idea of what's going on here in the y direction. So let me change my window. X min, let's go -10 to +10 for my x max. And then for my y min, I don't even drop below the x-axis, so my y min could be 0. My y max, I want to go up a little higher. I want to go up to 25 because I want to get a good idea of where it's crossing. So here's my graph over here. Okay, so this is definitely a parabola that opens up. We know that because it's the value of 2 out front is positive because this is 2. So parabola opening up. Now if I want to find this vertex, it kind of looks like it's about 2, 1 or 2, 2, 2 on the x, maybe 1 or 2 on the y. To find out for sure, I can go to second calc, and then I choose whether that was a minimum or a maximum. Well, you can see pretty clearly that it's a minimum. So we go down and choose minimum. And then it says, what is the left bound? Well, this flashing star says, I want you to find the minimum between this point, and then it asks for the right-hand side, and you can either move your arrow or put in a value, either one. And anywhere to the right is fine. And then to do your guess, you just kind of go over about where you think it is. It doesn't have to be exact. You say, okay, find my vertex. Now the vertex here, my x value is essentially 2. It's if you round this, it'll be 2, and my y value is 2 as well. So it doesn't give me an exact value, but it is pretty close. So we want to go with 2, 2 there for the value of that vertex. So that's one thing that you can do, but before you do that, it's a good idea to graph it and then try and determine, is this a maximum or a minimum point? So graphically, on your calculator, we can look at this and we can come up with the vertex, and we have to type it as an ordered pair, 2, 2. So again, that's given right here. Now by hand, what we would do is we would say, okay, this is in standard form, and because it's in standard form, I know A is 2, B is -8, and C is 10. And then I use that formula from up above that said x equals minus b over 2a. Okay, so minus b over 2a. Well, b was a -8 and a was a 2. Minus a negative is the same as a positive. 2 times 2 is 4. 8 over 4 is 2. So I know x is 2. And then to figure out what y is, I plug 2 back into my original. So everywhere that there's an x, I plug in this value of 2. So I come up here, I plug 2 in here and here. And you could also go back to your calculator and plug that in, or use your second table function and just look up 2 on your table and it would tell you that as well. So by hand though, we have 2 squared is 4, minus 16 plus 10. So 8 minus 16 plus 10, -8 plus 10 is 2. So this is the y value. So I know x is 2, and now I know y is 2. So again, my vertex is at 2, 2 for my handwork as well. Let's go ahead and jump into your calculator. And let's go to second table and see what our table tells us. Okay, so here we go into second table. Okay, so if we look at our table, here's this point 2, 2, and if you notice, 2 is the lowest value that we see here. All of these values are higher, so are these. Also see a lot of symmetry here. Notice it goes 4, 4, 10, 10, 20, 20, and we'll use that in a little bit. But this tells us my value for if my x is 2, y is 2. So you can come over here and find that value as well. So that's how we can find the vertex, either given standard form or non-standard form. Kind of just depends on where we start. Now another homework problem that you're going to be looking at has to do with actually graphing one of these problems. So you're going to be graphing using the graphing tools in MyMathLab. So I want you to be familiar with those. But before we can actually use the graphing tools, we have to do a little background work. So here's the problem, and then I'll open up MyMathLab 2 when we actually do the graphing. So they're asking us quite a few things here. First of all, use the graph to determine the domain and the range. And they also would like us to equation of the axis of symmetry. So it looks like we have quite a bit going on here. So to get started, let's think about what the vertex is here. So I have y equal x minus 3 quantity squared minus 4. My vertex is going to be opposite of what's inside here, so it'd be positive 3, negative 4. So let's do that. Let's do, starting at 0, positive 3, 1, 2, 3, 4, down 4. So this is my vertex. Now also, I know that this is a parabola that opens up. So this is positive. It's a positive value outside the parentheses there, so this opens up. Well, the problem is I don't know how wide it is. Is it this wide, or is it this wide, or is it really wide? I don't know which one of those is correct, and so that's why I have to go through and find a little bit more information here. I need to figure out how wide this is using the intercepts. Okay, so let's go ahead and talk about finding those intercepts. So if we look at the intercepts, I think the easiest thing to do is to let x equal 0. So this is our y-intercept. Okay, so for x equals 0, what we would do then is we put a 0 in for x and then solve. 0 minus 3 is a negative 3. Negative 3 times negative 3 is 9. 9 minus 4 is 5. So that tells me that I have an ordered pair of 0, 5 for my y-intercept. So here's 0 and then up 5. This is my y-intercept. This is my vertex. Now the cool thing about your intercepts then, and the fact that we have a parabola, is they have symmetry. So this is called my axis of symmetry, right down the middle here, and it's going to go right through my vertex. So with my axis of symmetry, that's whatever the x value is. In this case, x equals 3. Now it's called the axis of symmetry because this point that's 3 units to the left of the axis will also have a symmetrical point 3 units to the right. And so now I know how wide my parabola is. So I have my axis of symmetry, I have my y-intercept, I have my vertex. Let's go ahead and sketch this in. It'll look better when we sketch it in MyMathLab. It won't have that little wobble that I have over here. And that kind of gives me an idea of how wide it is. Now the only thing we don't have here are where it's crossing the x-axis. So let's go ahead and look at intercepts again. And here we'll let y equals 0 for your x-intercept. Okay, so these sometimes aren't as easy. Sometimes you don't get nice little solutions for this. So we'd set our equation equal to 0 and solve. So I'd add the 4 across. So I get 4 equal x minus 3 quantity squared. And then I take the square root of both sides. So this is from previous homework that we've done. The square root of 4, I would look at this as plus or minus 2. And on the right hand side I have x minus 3. Add 3 to both sides. Whatever you do to one side, you do to the other. And I get 3 plus or minus 2. Well, that's 3 plus 2 and 3 minus 2. So I have 5 and 1. So my x-intercepts are 5, 0 and 1, 0. So let's come up here and see how close we get. 5, 0 looks like a good spot, and here's 1, 0. So it looks good. So this is my x-intercept of 5, 0. And this is my x-intercept of 1, 0. And I didn't write in what my y-intercept was, but it's up here at 0, 5. And of course my vertex was, what did we decide, 3, negative 4? Okay, so this graph is a big mess now, but all the information is here. Now the only other thing we haven't talked about is domain and range. So for our domain, remember, for any parabola, it's all real numbers, because there's no restriction on what I can plug in here. And notice this graph will eventually extend very, very wide. Now my range are vertical values. So vertically, if I look at this, the graph doesn't even start until negative 4. And I bracket negative 4 because I actually reached that value. And then it runs off toward positive infinity, and then I'd close parenthesis. So there's everything about this graph. It's all right here. Domain, range, axis of symmetry, everything that we have there. So let's go ahead and pop open the same problem in my math lab, and let's see how we might go about graphing this. Okay, so first of all, it says use the graphing tool, use the vertex and one of the intercepts. So to use the graphing tool, and I can make the graph bigger, kind of makes it easier for me to see, I'm going to graph the parabola, and if I remember correctly, our vertex was at 3, negative 4. So I'm using my arrow keys once I select the vertex, but I have to get it selected first. Now if you notice up here in the top right hand corner, if you're not sure what this point is, you can come up here to check. Right now I'm at 4, negative 2. I want to be at 3, negative 4. So let's very carefully try to move this. 3, negative 4. Okay, so I have that point marked, and now you can see I can change all sorts of things here. I can make it narrower, wider. I know one of my intercepts for the x-axis was at 1, so I could graph that, or I could graph the other one at 5, or I could come up here and graph my other intercept at y as well. So this shows I have my vertex, I have my y-intercept, and I just go ahead and click save, and I can check my answer. And then from here we'll do our axis of symmetry, which I believe was x equal 3, so we have to do x equal. Domain, negative to positive infinity. Remember, whenever you use infinity, you have to make sure that, you're using parentheses and not brackets. There's a shortcut on your keyboard if you don't want to come over here and use the infinity palette. If you use the /INF, that will put an infinity, close parenthesis. Now what I forgot to put in here, the fact is this was negative infinity. And then the range was the bracket, and I believe we started at negative 4, and then we went off toward infinity. Yep, so that's how we would graph one of these functions. So the My Math Lab part of this isn't too difficult after you kind of get used to that graphing tool. And remember, you can make this graph as big as you need to be able to see where those points are, so you don't mess up on a point of intersection. Now we can also work with this on your calculator to double check some of these points. So let's go ahead and pop open your calculator as well. So here we have, whoops, where's the calculator? See if we can track it down. Let me try and reopen that again. Okay, here we are. So we want to go into y equal, and our graph for this case, I believe, was x minus 3 quantity squared. Whoops, to get that exponent in there. So x minus 3 quantity squared, and then we had a minus 4. So we could graph this and then kind of compare it to what we thought the graph looked like. and see how close it is, and we can see it is the same shape. Vertex is down here. If you want to double check your vertex, remember you go to second calc. This is a minimum, and there's our left bound, and then we could arrow over or just plug in a value. We want to be to the right of that minimum somewhere. Doesn't matter where, as long as you're to the right. And you can go over for your guess, or you can leave it where it's at for the right bound. And it tells me that my vertex is at 3, -4. And then if I wanted to check my Y-intercepts and my X-intercepts, I could go to second table. And oh, here, right here, there's my Y-intercept 0, 5. And here's my X-intercept 1, 0. And here it is 1, 0. And here's my other X-intercept 5, 0. So this gives me those table values very easily and very quickly. But if they were decimals or fractions, it would not give me these values. So you have to be a little bit careful about that. So again, graphing, being able to use that second calc max or min they're really going to be helpful to you. They really help out a lot. And then talking about the domain and the range and the axis of symmetry as well. There's one other kind of complicated problem that I want to make sure that we work through. But again, one of the best things that you can do is always graph these. Now, you won't be able to graph all of them on your calculator. Some of them you will just be able to do a quick graph by hand. For instance, let's go ahead and look at one of your harder problems in my math lab. And for this one, they're going to give you just a little bit of information. They're going to give you the minimum point and ask you to find the domain and the range. So for this one, I can't graph it on my calculator, but I do know this. I do know that my minimum value is -8 at x = 4. So that's the ordered pair, 4, -8. Okay, so if I wanted to, I could graph that. And because it's a minimum, let's say this is -8 and this is 4. Because this is a minimum, I know that this parabola is opening up. I don't really know how wide it is, but this is just a curve sketch. So it asks for the domain. The domain, we know, for any parabola opening up or down is all real numbers. And the way that we'll represent that in my math lab is from negative to positive infinity. Now my range, because I know it's a minimum, remember range is vertical, domain is horizontal. So vertically, it looks like I start here at -8 and I shoot off toward positive infinity. I actually reach -8. I don't reach positive infinity. You never reach infinity, positive or negative. So that is where I'd have my parenthesis. So even though I can't graph this in with your TI, you can do a quick hand sketch that will give you a lot of information about this. Okay, one last question that usually causes quite a few points of confusion for students. I want to make sure that we go over it, so if you run across it in your homework, it will be easier for you. Okay, so let's go ahead and look here. It says, find the axis of symmetry for the parabola whose equation is given. Use the axis of symmetry to find a second point on the parabola whose y-coordinate is the same as the given point. So that's almost confusing. The directions are confusing. So what this is saying is graph this and find this ordered pair, and then find the ordered pair that's symmetric to it. Okay? So let's go ahead and graph this in with your calculator. So let's do 2x plus 3 quantity squared minus 4. So y equal 2x plus 3 quantity squared, and then minus 4. And hit graph. Let's graph it. Okay, so I'm going to use the idea of axis of symmetry, it says. Well, let's go ahead and find the vertex. I think we can look at this and know the vertex is at -3, -1. But let's go ahead and pop in here and see. So f of x equals 2x plus 3 quantity squared minus 4. So our vertex we can get from here. Remember, it's opposite of what's in an x, and then the y value is just what's on the outside. So I know the vertex of this parabola is -3, -4. This is positive, so I know it's opening up. So I know that this is a minimum point. And I also know that my axis of symmetry is right here, and it's whatever the x value is, which is -3. So I have all sorts of things going on here. But let's pop back into your calculator. I want to expand this just a little bit so I can see a little bit more what's going on. I don't think I need to do -10 to 10 here. I could probably do -5 to 5. And again, this is just my preference. You don't have to change yours if you can see what's going on. And let's do -5 to 5 here as well. Whoops, I'm going to change that value. I want that to be a 1. Let's change it 1. And then so -5 to 5. Now I'm looking down here and I want to go a little further on my x. Oh wait, here it popped open. Now that does look like a nice graph. So let's go ahead and hit graph. And then let's pull that into our lecture so we can kind of see what's going on here as well. This matches with what we thought it should look like. So we knew it was a parabola, we knew it was opening up, we knew what the vertex was. Actually, before we copy that, let's double check the vertex. Second calc, minimum, left bound. I don't even see the left bound. It says it's at x equals 0 right now. So left bound of this point would definitely be something over here like -5. So I'm just going to put in -5 for my left bound. And then right bound would be somewhere over here, let's say at -1. And you could choose all sorts of other values. And then the guess, you can just leave that if you want, or you could come down here and take your guess. It doesn't matter. And so it says the minimum is at -3, -4. So let's put that into our lecture notes. So -3, -4. Okay, so vertex matches exactly what we thought. So down here we have our vertex. So that's vertex at -3, -4. Our axis of symmetry splits this right in the middle. So that's x equal -3. It's whatever our x value is for my vertex. And so I think I've answered a lot of the questions here. It says, find the axis of symmetry, and it says, use the axis of symmetry to find a second point on the parabola whose y-coordinate is the same as the given point. So for our example, they give us the point from right here. Now the given coordinate that they give us to work with is right up here, and it's the coordinate -2, -2. So let's go ahead and plot that point on our graph. So if we go over -2 in the x direction and -2 in the y, that puts us right here. So this is the ordered pair -2, -2, and what the question is it says find the other coordinate on this parabola that has a y value that's the same as the coordinate given. So we're looking for -2, -2. So that's going to be straight across right here. And if we look at our x value, then we know our y value is -2. Our x value is -1, -2, -3, -4, -2. So the coordinate that we're looking for then that has the same y value as -2, -2 and is symmetric is this ordered pair -4, -2. So this is what you put in for that value. As usual, if you have any questions, please let me know.